All right, welcome to the new unit. This is on parallel and intersecting lines. So please listen. First, let's talk about how two coplanar lines might intersect. Well, they could be sitting on a plane and not intersecting at all. We call those lines parallel. We could have two lines that overlap, that have one point of intersection. Those are called intersecting lines. Or we could have two lines that are overlapping completely, where they share every single point of intersection. Those are called coincidental lines. Now, if we have two lines that meet are intersecting, we produce some lines and we produce some angles. This is angle 1, and it has a relationship with angle 2. Do you know that relationship? Some of them are linear pairs. Angle 1 and angle 2 form a linear pair. Does angle 2 have a linear pair relationship with anyone else? 3. Yep. 2 and 3 have a linear pair relationship. Does 3 have a relationship with anyone else? 4. It does. Good. So there's 4 sets of linear pairs in this single interaction of two lines. Now we've also got angles that are called vertical angles. Angle 1 is a vertical angle with what angle? 3. Good. Angle 1 and 3 form vertical angles. Whereas angle 2 forms a vertical angle with, good, 4. Once we identify that angles have this relationship, we have the opportunity to talk about the relationship consequences. If angles form a linear pair, then they are what? Adjacent. Ooh, good. They are adjacent, but more importantly, supplementary, which incorporates both adjacent and adding to 180. Whereas vertical angles are congruent. Excellent. If your knowledge about linear pairs and vertical angles doesn't allow you to pick out pairs like this, and your knowledge about linear pairs doesn't say that they're automatically supplementary, your knowledge about vertical angles doesn't say they're automatically congruent, this is knowledge you need to memorize. This is important in this unit. This goes on flashcards. Let's step it up a little bit. Let's say what happens if you have 3 lines intersecting? Well, they can be parallel again. They could be coincidental again, but neither of those has any interest to us because no angles are created. Once they're intersecting, we could see them intersect like this, where there's 3 individual points. We could see them intersect in some single point of intersection. But there's nothing really fascinating about those. Because what kind of angles are formed here? Anything new, or is it just linear pairs and vertical angles? Nothing new. Nothing new. We've got linear pairs, actually linear triples also, things that form straight lines, and then vertical angles. So nothing new there. What if I look at this scenario? Oh. Still, I've got linear pairs, and I've got vertical angles, just 3 different sets of them. Can we agree that there's no relationship between this angle over here and any of these angles down here? Those are totally unrelated. I could move this line here and it wouldn't change things. But what about this scenario? Now we could take an angle up here and an angle down here, and there's a relationship between them, even though they're not linear pairs or vertical angles. This is what this unit is all about. So let's start by talking about names. If these 2 lines are drawn in such a way that they may be parallel, may not be parallel, and yet there's this other line crossing over them, this is called a transversal. But for our purposes for today, I'd like you to visualize this is a river. Can you see the river? And this thing crossing it would be like a what? Good. And we're going to name the angles based on that knowledge that this is like a river and this is like a bridge. So the first part is how the angles are related to the bridge. These 2 are on alternate sides of the bridge, right? One's on the left, one's on the right. These 2 are on the same side of the bridge. Now we're going to talk about whether they're wet or dry. Are they inside the river, in the interior, like these 2 are? Or are they exterior to the river? Here's the river, they're on the outside of the river. So these 2 are on alternate sides of the bridge and interior to the river. Therefore, we call them alternate interior angles. These two are on alternate sides, but exterior to the river, so they're alternate exterior angles. These two are what? Same side, interior. What are we missing?
Same side exterior.
Good. Can you visualize where the same side exteriors would have to be? Like maybe up here or over here. Same side exterior. And then there's one more name, a fifth name. It doesn't quite fit this whole analogy. It's called corresponding angles. And what it means is if you look at this top intersection, where would you describe this angle is in this top intersection? Bottom left sounds great. Where would you describe angle 4 in this intersection? Also bottom left. In other words, those two angles are in corresponding position. And if you try to use our naming convention and you find that they're on same side, but they're also one wet and one dry, that's when you know it's corresponding. Let's see. Can you visualize, please, where in this picture you would expect to see alternate interior angles? Maybe there or there. Can you visualize, please, where you would expect to see alternate exterior angles? Right? How about same side interior? Same side exterior? Corresponding. There's more in this one. How many sets of corresponding angles can you see in here? Good. 4. There's 1, 2, 3, 4. All right, let's see if you get it. 2 and 6. Don't say it out loud, please. Hold that thought for a second. Look at these and decide which naming pair relationship we're going to use. On the count of 3, I want you to say it out loud. 2 and 6. 1, 2, 3. Excellent. Those are corresponding. Please now look at 3 and 6. Don't say it out loud. Don't cheat others out of the experience. You're saying it out loud. Don't do that. On the count of 3, please tell me what it is. 1, 2, 3. Alternate interior. Good. How about 1 and 8? Don't say it out loud. Think about what that is. On the count of 3. 1, 2, 3. Good. Alternate exterior. And last one, 4 and 6. Count of 3. 1, 2, 3. Same side interior. Okay. I'm going to now pass out today's worksheet. Okay. Come on back together, please. Please be quiet. Let's fill in some initial vocabulary first. A line that crosses parallel lines, or even non-parallel lines, to create pairs of angles that we're going to be naming. What do we call the bridge? Very good. Transversal. I would. And then these two words are going to come up a lot. When we have two angles that have the same measurement, those two angles are considered congruent.
What same angle?
They have the same size, same measurement. And then if we have two angles that add up to 180, what does that mean they are? Good, supplementary. And I'd like to suggest that next to the congruent one here, let's write something. Measure of angle A equals measure of angle B, because they're the same size. Whereas the supplementary one, we'd say the measure of angle A plus the measure of angle B equals how much? 180, good. So today's lesson has three parts. One, naming these angle pairs, identifying them. Two, we'll talk about whether that makes them congruent or supplementary. And then three, there's an opportunity to do some algebra to refresh those algebra skills in solving. So the first step is naming them. You'll notice down here it describes some angles. Angles that lie on the same side of the transversal and on the same side of the parallel lines. Like this pair is both left of the transversal and above the parallel lines. What do we call these angles?
What was?
These X's that I've drawn here.
Okay. Right, no, not congruent. So what's the other one that you use?
Corresponding. Okay, I'd like you to please read these, draw a picture that matches them, and then write the name there. Work together with your neighbors, figure out how to fill in these words. Go. Okay, please take a look and see if you got the same answers I did. Corresponding for the first one. Alternate interior. Alternate exterior. Everyone looking up here? I hear some chatter. Make sure you got the same answers I do. Any contentions or questions or challenges?
Vertical.
Because it said that they're opposite each other from any intersecting. So we're not talking one from the North Shore, one from the South Shore, as is true of all the rest of these. Any questions? Would you please flip to the second page and show me that you can name these angle pairs? Do numbers 1 through 4 now. Go. Sure. All right. Let's see. Number 1, which angle is alternate interior with number 4? 6 is correct. Those are alternate interior angles. Which angles are same side interior with number 3? Also 6. Who's the favorite, huh? All right. Which is alternate exterior with 2? Good. 2 and 8 are alternate exterior. Which one is corresponding with angle 1? 5. Upper left, and 5 is upper left. Yep.
For the relationship between 4 and 3, great stuff, right?
If you wanted to talk about the relationship between 4 and 3, you'd write linear pair, then supplementary. We'll get to that in just a second. Now, I have to take you off on a little bit of a path here. Do you remember when we talked about the difference between a theorem and a postulate? Both of these are rules that we're going to use in geometry, and they're going to guide much of our work. Please be quiet. Would you guys please be quiet? Both of these are rules that are going to guide our geometry, and we're going to write them as an if-then statement. That's why we learned about if-then statements. Postulates are rules that are not proven. We're just going to accept them without proof. Whereas theorems are proven. So they're stronger. We don't want to accept many things as postulates because it's weak. But sometimes it's so obvious we're not worried that it's really going to be a problem. We already have two postulates. What are they? Good. The segment addition postulate says that if I know that I've got a straight segment with one point marking in between, that AB, the length from A to B, plus BC will always equal what? AC. In other words, if this is 5 and this is 3, how long is the whole thing? 8. No problem. And then we have the same scenario with angles. If I know that this is 50 degrees and this is 20 degrees, then how long is the whole, or how wide is the whole angle? Easy, right? This is the segment addition postulate. This is the angle addition postulate. We're going to accept those as true without proof. In the same way now, we need to do the same thing with this new thing. Because what I've got is this idea that if I put an angle here, I don't know, let's say 100 degrees, I can find information about each of these. How big is this angle? 80? That was fast. How did you know that? Because it's a linear pair. And we know linear pairs are supplementary. So we could say 180 minus 100 leaves me with 80. So this angle is 80 degrees. What about this angle over here? 100, because what's its relationship to this one? Vertical. And vertical angles are congruent. So that's got to be 100. How about this one? 80. Either because these make a linear pair, or these make a linear pair, or these are vertical. But what I want to do is I want to bring in one from the North Shore and one from the South Shore. So let's say that I've got them sitting like this. If this is 100 degrees, can I say anything about this angle? Is it 100 degrees? Depending on how I move this line, won't it change? So where will it be that this angle would be exactly 100 degrees? What would be the relationship of this line? You guys agree? Parallel to the other? Another way to kind of prove that with yourself is, what if I started with these just overlapping here? And then I copied and slid or translated this down. If I keep it so that this line is still oriented, isn't this line still parallel to the original? And if they're parallel, then these two angles will end up being the same. Can we all agree to that? So this is going to create for us our first postulate for this unit, our only postulate for this part, which is if parallel lines, then corresponding angles are congruent. If the lines are parallel, then these two angles will be the same. And of course, if this is 80, how big is this one down here going to be? Those will be the same because they're corresponding and because it's a linear pair again. So all pairs of corresponding will be congruent. Agreed? But what if I figured out this angle? How big is this angle? 80 again. And what do you notice about these two angles? They're congruent. And what's their named pair relationship? They're not corresponding. Alternate interior. And so what we're going to prove, not today, next class, or Tuesday, Wednesday, is that if the lines are parallel, then alternate interior angles are also congruent. And if this is 80 and this is 80, what kind of named pair relationship do these two have? No. Vertical angles have to share a vertex. These two are vertical.
No, alternate.
Alternate exterior. And aren't they going to be congruent also? Again, we'll prove this in a couple classes. Now let's take a look at these two. What's the relationship between those two? And are they congruent? What are they? Supplementary. Okay, and what about those two? What kinds of angles are those? What do we call those? And they are what? Congruent or supplementary? Supplementary. So again, we'll prove these four because these are going to be theorems for us. And this concept is like 75% of this unit. You need to identify these different angle pairs. You need to know if they're congruent or supplementary. You'll need to solve problems associated with it. And you're going to be responsible for proving these. We'll walk through all that. But for now, the thing people struggle with here is memorizing which ones are congruent and which ones are supplementary. So corresponding and alternate interior and alternate exterior, those are all congruent. Whereas same side interiors are supplementary and same side exteriors are supplementary. If only there was some way we could remember which ones are supplementary. Anyone have any ideas? So they start with S's. Same side interiors are supplementary, same side exteriors are supplementary. So look for the S's. That'll remind you which ones are supplementary. Please take that knowledge and transcribe that onto today's notes. This little chart down here. Pull from these 5 words which ones are congruent and which ones are supplementary. Go. It will be, but right now we're doing notes. Nope. Yes. Well, and linear pair. It's up to you. If you want to add vertical angles in the congruent side and linear pairs in the supplementary side, because those need to be there at some point, that's fine. Oh my God. Okay, easy peasy. So we got corresponding here, AIA here, AEA here, same side interior, same side exterior. So how are we going to use this? Here's a problem. This is the type of thing you're going to get for today's homework. You've got a graph that shows 2 lines. It tells you up here that these 2 lines are parallel. And therefore, these 2 angles have a certain named pair relationship. What is that relationship? Good. Alternate interior angles. Then ask yourself, because of that, are those congruent or supplementary? Good. And because of congruent, that means we set the equation how? We set them equal to each other. Divide by 3, divide by 3. This is now where algebra comes in. So for all these, you're going to name the angle pair, pick whether it's congruent or supplementary, and that determines what your equation is, and then solve. So flip to the next side. Let's go to number 5 here. What type of angle pair are these 2? Good. Same side exterior. And are those congruent or supplementary? Supplementary, which means what's our equation? I'd rather you write x plus 77 equals 180 and then solve that. Yes. All right, your homework is to finish this packet. It's just like this for the rest of the packet. What you'll find is this page is just straight numbers. The second page is very basic algebra. And I'm going to pass out another page. This other page is more complicated algebra. If you're somebody who believes in your good algebra skills, but just got an algebra skills survey that says you're rusty, I strongly encourage you to do this additional page. It's not extra credit. It's not bonus points. It's not going to put you in an honors program. It's just to address the skill gaps that you just addressed. This is what you're capable of. If, however, you've already demonstrated your algebra, you just want to compare an input here, you don't have to.